everyone, again welcome back to the YouTube channel. My name is Rukami Escasbuena from ECE31, and for today's episode, we will be focusing on our Digital Electronics Laboratory Experiment number 1, or the digital output. We have our objectives here, which is first, to learn how to create a project and build a project using the Mplab softwares. Second is to understand how the final code program to the microcontroller or the Pickit or our IC, and to create a simple code for controlling our LEDs. So for our equipment and components, we will be needing an IC, specifically this model, which can be bought from Microchip, and then we will be needing 280 ohms resistor, an LED, a breadboard, connecting wires, our Pickit3 or 4, and our power supply. It could be a battery or a voltage source that could be stepped down using our power module. So we just have to follow the procedures for our experiment number 1 to be able to perform it effectively. So let's start. Perform our experiment number 1, wherein we will be controlling our LEDs by programming. Using our IC and our Pickit3, we will be needing the Mplab XIDE software from our desktop. Now we will be creating a new project here, so let's click it. And then it should be Microchip embedded. And then make sure that it is a standalone project. And of course, for this experiment, we will be using our device as the PIC165F18875, which is the IC that we bought from Microchip. Then we have to click Next. Okay. And in this part of the Mplab, we have to select our compiler, which is the XC8 here, which is the highlighted one. And then we will be clicking Next. Then, of course, we have to rename our project, which it's up to you, of course. So I want to name it with my surname and then my initials, and then experiment number 1. So here you have to select where do you want to save your project. So I want it to be organized. I want it to save here in our LX laboratory. Okay, and you just have to click finish after that. So you just have to wait patiently because it takes time before our work area load. But after that, we will be programming already with our IC and with our Pickit3. Then after loading, we should go to Tools, Embedded, and then the Mplab Code Configurator here. We just have to click Tools, and then Embedded, and then our Mplab Code Configurator here. So let's just wait for it. And there will be a pop-up here. We just have to save it. Okay, and then after that, so as you can see on our screen, we have 3 peripherals, which is namely interrupt module, pin module, and then the system module. The system module, the interrupt module, and the pin module will all be automatically included when we launched our MCC. Then on our pin manager here, we have to click on our port A or our pin 4. Okay, so this is the port A, and then pin 4 output blue lock symbol. So our output should be locked. Okay. So this output 4 should be locked, and then this input should be in color orange, as you can see here on our screen. This pin 4 here will be connected to our D2 LED later on when we run our code on the LED. It should turn green, and this adds this RA4 pin to our project. So this should be green and this should be orange. Then we should go to pin module here, and we will be editing our settings here. So our RA4 pin will be made an output pin, and it should control the LED. We should click here on our output box to make the pin an output, and we have to uncheck WPU and analog boxes. Then change the RA4 pin name to LED2. So LED2. So that's our pin module settings. Then notably, we should just disregard this IOCs. And then we should go to system module, and we will be editing our system here. So our oscillator select should be HFINTOSC. We should select it from our drop-down menu, and then our HF internal clock should be 4 MHz, and then our clock divider value should be 4. This will enable the internal 1 MHz internal oscillator as the system clock. And also, most importantly, we should tick here the low voltage programming enable. which is selected at the bottom of the system module screen. Then we have to generate code button to have the MCC create the software libraries for this project. So we have to generate it by clicking here. Okay, we have to generate our source code. So we just have to wait for it because the software is generating our code for the MCC file. Click that one. After generating, we should see here some headers, okay, both generated header files and source files, and it should also have a generated main C file. So we can see the generated main C file here on this end, and on this area, we will be typing our code. So we have to type this code here. So our delay should be 250 milliseconds. So this means that the LED will blink for this time duration, and then we should rename our LED D2. If you can still remember, we set the name of our LED to LED D2, and then we should put toggle. And then after that, you should type semicolon on our code so it would run. And after that, we should click build, okay? We should click the hammer here on the top of our screen to be able to compile our code. And after that, we should just wait for it. And after that, there should be a pop-up here which would say build successful. And after that, make sure that our project has the Pickit3 selected and a USB cable is connected to our computer when we build our project. So let's rebuild it. Okay, so we're done with Mplab IDE. So we will be going to Mplab IPE. So now we will run our Mplab IPE software here. So let's just wait for it to load up so that we can connect our Pickit3 and our IC circuit to our Mplab IPE, and then we will be able to program our IC. So let's just wait for it. So let's maximize it. Okay, so it already recognized our Pickit3 here connected to our computer. Try to connect our Pickit3 to our Mplab IPE. So as you can see, there will be a caution message here. So let's just click OK. And let's wait for it. Okay. So as you can see, it says the target device was not found, could not detect target voltage VDD. So you must connect to a target device to use Pickit3. So we will be editing our settings here to solve this error on our Pickit3. Settings and then advanced mode, and then it will require a password. So the password is microchip. So let's log in. And then on our settings, we have to select our advanced mode. We have to double click here on power, and then we have to change our voltage level to 3.125. So here, and then let's pick this power target circuit from Pickit3. Good already, and we go back to operate. And now we have here our Pickit3. So we will be connecting it to our Mplab through our USB cable here. So let's connect it. So as you can see, so on the screen, I will show you the legends for the basic parts of our Pickit3, and I will show you the meaning of each of the color here on our Pickit3. So for our green, it indicates our power for Pickit3. The power is supplied to the Pickit3 via the USB port, as you can see here, the red wire here. So for the blue color here, it means active, meaning it is connected to the PC USB port and the communication link is active. So it means it is functioning well. And then our third color here means our status. Okay, so if it is color green, meaning it is ready to start or it is a successful completion of our code, and then if it is orange, meaning it is busy with a function in progress. And third, if it is red here, it means there is an error occurred in our code. So that's the part of our Pickit3. So here on our Pickit3, we have here an arrow. So that's our pin 1 indicator. So since with my Pickit3, I already have this joint wire here, which will be connected to this black part of our Pickit3. So I will set the yellow wire as my connection to pin number 1 of my IC later on, and the pin number 1 of my Pickit3. So let's connect it. So if you have this kind of wire, so it is better because it will be more convenient for you for connecting your Pickit3 to your IC and to your breadboard.
So for our Pickit3 pin description, so the number 1 or the pin number 1 will be for the VPP here, which is on the arrow is pointed. So that's our pin number 1 or our VPP. And then our pin number 2 here, which is the orange wire, will be our VDD target. The number 3 will be our VSS or our connection to the ground. And then for pin number 4, the brown wire here, it will be our PGD or ICS PD80. And then our pin number 5, which is the black wire here, will be our PGC or the ICS PCLK. And the pin number 6 is PGM or LVP, or sometimes it is not connected to our breadboard. So that's our pin description or pin configuration for our Pickit3. It's really important. So now this time we will be connecting our Pickit3 to our programmable IC here. So it's the PIC 1618875 IC here on the breadboard. Now you have to take note that this IC has 40 pins, and you have to take note of the notch here of our IC, which is our mark for the first pin. So we will connect the Pickit3 pin number 1, which is the yellow wire here, on our pin number 1. Okay, so let's just connect our Pickit3 here on our breadboard first. So let's connect it here. Okay, so that's our first connection. Now, for your convenience, I will show you the pin configuration of our C116F18875 IC here on the screen. So we will be connecting the pin number 1 of our Pickit3, okay, this yellow wire here. We will be using our connecting wires. So we will connect the pin number 1 of the Pickit3 to the pin number 1 of our IC. So this one, okay. So for our VDD here, which is the pin number 2 of our Pickit3, which is the orange wire, let's connect it to the pin number 11 of our IC, which is the VDD as well. So let's count. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So this pin here. So this will be the connection. Then we have our VSS on our Pickit. Let's connect it to the pin number 12 of our IC here. So after this orange wire. So that's our connection. Now let's connect the PGD of our Pickit3 to our 48 slot, okay, to the 48 slot of our IC, so and the other side of our IC. And then let's connect our PGC or the 5th pin of our IC to our 39 slot. So that's the color black. So let's connect it using this green wire here. So let's connect it to the 39 slot of our IC. So this will be our connection, and we will be connecting this to our Mplab software.
And now, after setting up our settings for our operation, we will be browsing our hex files. So we should browse here the hex files that we created for our experiment number 1. So let's go to this and then default, and then this will be our hex file here. So after that, let's click program. So our Pickit should be connected to our computer so that it will be programmed by the source code that we created. And there should be a pop-up here saying programming complete. So we will be testing if the program is correct, which will be displaying the blinking of our LED.
Now in this part, we will be testing if the program is correct and will make the LED blink for 250 milliseconds. So first, we program the RA4 of our IC. So our RA4 is here on the 6th pin of the IC. So let's connect a wire. 1, 2, 3, 4, 5, 6. So we will be connecting an LED on this pin of our IC. So here's the LED, and we will be connecting a 220 to 360 ohm resistor so that the voltage will not be overloaded on our LED and it will not explode. And then let's ground our LED here. So let's ground it here. And after that, we will be connecting our VDD and our VSS. So our VDD will be on the 11th pin of our IC. So from here, 6, 7, 8, 9, 10, 11. So our VDD will be connected to the positive supply, and then our VSS should be grounded, which is our 12th pin. So let's get a gray wire here. So our VDD should be grounded. So our VSS and VDD on the other side of our IC should be connected to the ground and the voltage supplied as well. So our VSS is on the 31 pin. So from here, 40, 39, 38, 37, 36, 35, 34, 33, 32, and 31. So this should be connected to our ground. And then our 32nd pin of our IC, which is the VDD, should be connected to our voltage supply here. So this will be our circuitry for our experiment 1. So now let's test if the program is correct. So let's now turn on our power module. So as you can see here, the LED is blinking or turning off and on for 250 milliseconds time duration. So that's our LED here, meaning our source code is correct.
So now to program our second part of experiment number 1. So let's go to our main C file here. So we will be programming and we will be modifying the code in our main.c file such that the LED will blink at 2 seconds interval. So if it's 2 seconds, so meaning it's 2000 milliseconds. So let's just build our program here. So let's wait for it until the build will be successful. So here on the Mplab IPE, again, let's check our settings. Okay, let's just wait for it. And now let's just check our settings here, advanced mode. And again, our password is microchip. And then let's check the power. Again, let's set 3.125 for our voltage level, and then power target circuit from Pickit3 should be picked. And then let's go to operate. Let's browse our new hex file here, so our experiment 1 here. So let's open, and then we will be programming here. So we will click the program button here. So let's just wait for it. So now let's click program. So this will program our device, and it will take time for our IC to be programmed. So it says here, programming complete, and after that, we will be testing it on our IC and our circuit.
Now, after programming our IC for it to be able to let the LED blink for 2 seconds or 2000 milliseconds, so here's the output. Let's turn on our power module here. So as you can see, the LED is blinking or turning off and on for 2 seconds. So let's count. 1001, 1002, 1001, 1002, 1001, 1002, 1001, 1002, 1001, 1002, 1001, 1002. So that's our experiment number 1, which enables us to let and control our LED for the time duration of their function by turning on and off or by blinking.
As our conclusion, the Pickit3 programmer debugger is a simple in-circuit debugger that is controlled by a PC running Mplab XIDE and Mplab XIPE. It is used for hardware and software development of microchip microcontrollers, MCUs, and DSPIC, digital signal controllers, DSCs. Technically speaking, using Pickit and Mplab IDE or IPA software, electronic components like integrated circuit and light emitting diode, just like in our experiment number 1, can be programmed and controlled in a circuit according to project requirements. So that's the end of our experiment number 1. I hope you learned from our episode 4 today, and I hope you enjoy programming IC using the Pickit3 with me, and I hope I will be seeing you on our next episode for today. So again, this is Rigami S. Casabana, and thank you for watching my blog. God bless!